number 12. Okay. Problem number 12 has to do with this hot air balloon. Okay, where you have something like this. This hot air balloon is let us say in the air, and what is asked is draw the free body of this upper part alone, this upper part alone. Okay. So, let us try and do that. For now, let me just remove the bottom part partially, so that it is clear to us. Now, again we go through the same exercise. This particular membrane in toto may have some mass to it, and therefore, there will be some mg acting. Let me just take that particular center of gravity to be somewhere here. So, this is the mg that acts on the body. Apart from that, there are many contact forces. One contact force arises due to the bottom part and the top part of the membranes interacting. Okay. And therefore, if I remove this bottom part, there should be an interaction force along this direction. Remember, it is a membrane, which means it does not resist in any other forces along the other directions, and therefore, I will have interactions of this sort. Let us call this as F per unit length. Because remember, it is a balloon and I am cutting it horizontally, and therefore, there will be a ring formed over here, and on this ring there is a force distributed all around the periphery, and therefore, let us call that as F per unit length acting on it. Okay. As you can see, the bottom also will have that equivalent opposite force, ring force that is acting. Okay. Okay. So, we have removed one other interaction and substituted with that force. What other interaction exists here? The other interaction could be due to the inside air, hot air, right. What is the hot air doing? It is applying a pressure on this. Okay. The pressure could be such that there is a variation over this particular entire thing. Okay. Let us call this as P over this membrane, okay, and that completes the free body of this particular problem. We will take up one more problem, which is problem number 13. This has to do with a branch of a tree. Okay. Let us say something like this. Let us say this is the tree, and it has let us say several branches as it grows. Let us say something like this. What is asked is, can you draw the free body of this particular subsection of the tree? Okay. Naturally, I will go through the same exercise here. One interaction is due to the gravitation, and therefore, let us say if the center of gravity is somewhere here, this is the mass of this set that I am taking, which is mg, and apart from that, there are other interactions. The primary interaction, if I do not consider the wind etc., is between the main stem of this particular bark of this particular tree and the branch. So, if I cut over here and examine what is this base providing to this branch, you can see that this base does not allow this point of this branch to move in this direction as well as in this direction, and it does not let rotation occurring in this direction. And therefore, I will remove this part of it and apply the conjugate forces that create that constraint. So, and therefore, I will have one force like this, another force like this. Let us call this point as A. So, we have A x prime, where I am sorry, this is A y prime. Let us say I am choosing directions of this sort for drawing the free body, and therefore, this will be A x prime, right, and it is also restraining the rotation, which will cause m a to it. That completes the free body of this particular branch of a tree.